Today we're going to be talking about geometric sequences. We've already talked about arithmetic sequences and how we can write equations or rules for those. And arithmetic, we remember we are adding and subtracting the same amount. When we are talking about geometric sequence, we are multiplying or dividing by the same amount to get the next term. However, we don't write them with a division symbol. So if we were dividing by 3, instead of writing divided by 3, we would multiply by 1/3, the reciprocal. So that's what we have to really focus on when we write these, is that if we're dividing, we need to multiply by that reciprocal. So one of the challenging things that goes into finding the rule is how do you get that rule or that rate, what you're multiplying by, when you're looking at the terms of the sequence. And we did this when we talked about and wrote equations of exponential equations. If we divided two adjacent terms, or two terms that are next to each other, then that will give us the R value, or what we're multiplying by. And that's what this says right here. So we can do a term, and it doesn't matter which one, divided by the previous term. That will get us our rate. That's how we got our B value when we wrote equations. So analyze whether the sequence is geometric and explain our rationale. So for this to be geometric, any term we take, so I'm going to do -4 divided by 1, that equals -4. And then 16 divided by -4 is also -4. So far it works, but we have to do it for every term. -64 divided by 16 is also -4. And then 256 divided by -64 is also -4. So since all of these divide out to be -4, it is geometric. Yes, the common ratio is -4. So we can have a negative common ratio. Now with this one, 128 over 512, that is 1/4. And then 64 over 128, that simplifies to 1/2. These are not the same. So no, there is no common ratio, because it doesn't equal the same when I divide two adjacent terms. Now down here, the explicit formula for a geometric sequence is this: a sub n equals a1, which is the first term, times r raised to the n minus 1 power. And that kind of looks like y equals a times b to the x, except our exponent is different. Instead of it being just a single variable, it's n minus 1. Let's look down here. For each sequence, write a rule for the nth term of the sequence, which is your explicit rule. Find the 10th term, and then write a recursive rule. So we are already told that these are geometric. So I'm going to do -324 over 972. That simplifies to -1/3. And if you are not told that this is geometric, then you should do this for all of your terms. 108 over negative 324. That also simplifies to negative 1/3, and so on. So this means that my r is 1/3. And again, our formula is a sub n equals a1, which is that first term, times your rate, raised to the n minus 1 power. So our rate is 1/3. A sub 1 is 972. That means my formula is 972 times 1/3 to the n minus 1 power. This is the explicit rule. Then ace of 10 is going to be 972 times 1/3 raised to the 10 minus 1 power. And we can just type that into the calculator. 972 parentheses 1 divided by 3 raised to the 10. Whoops, I didn't close the parentheses. I thought I did. Close parentheses raised to the 10 minus 1 power. And we get 0.049. If we wanted to make that a fraction, alpha y equals, go down to that fourth one. You see it's 4 over 81. Now the recursive rule, a sub n equals, we're multiplying by 1/3 each time, so it's going to be 1/3 times a sub n minus 1, that previous term, where a sub 1 is 972. This is recursive. Right now over here for this one, you may not be able to see, if you can see what the common ratio is without doing this step, that's fine. Like I think we can see here that we are just multiplying by 2 each time. So r is 2. So that means my explicit formula is going to be a sub 1, which is 14, times 2 raised to the n minus 1 power. This is explicit. A sub 10 is going to be 14 times 2 to the 10 minus 1 power. So again, I'm going to type that into my calculator just like that. Oops, not 9. I was going to say, if you wanted to type in just 9th power, you could. 71 equals 7168. And then your recursive term, your recursive rule, a sub n equals 2 times a sub n minus 1. So I'm multiplying the previous term by 2. And my first term is 14. So this is recursive. So you're probably saying that writing these rules today with geometric sequences are easier than when we wrote them with arithmetic sequences, and I would agree with you. But where things get a little bit more complicated is on the next page, where we have 2 terms and we have to find the rule for the nth term. When we were working with arithmetic sequences, we used that slope formula and calculated it from there. But with geometric sequences, it's a little bit different. So I'm going to do these 2 up here and then have you do this one down here. Okay, when we have two adjacent terms, we would divide them, and that would give us the r value. But these are not adjacent terms. We have a sub 2 and a sub 7. Well, how far are they away from each other? They are 5 numbers away. You know, the difference between 7 and 2 is 5. So the way we write that is we would say r to the 5th power. Actually, maybe I should write it this way. R to the 7 minus 2 power equals that 7th term, which is negative 320, over 10. Well, r to the 5th power, r to the 7 minus 2 is r to the 5th, equals negative 320 divided by 10 is negative 32. And then we have to take the 5th root of both sides. The 5th root and 5th power cancel. So r is negative 2. Okay, so far so good. R is negative 2, but we need to find a sub 1. So our rule, a sub n equals a sub 1 times r to the n minus 1 power. We need to find the first one. So a sub 1 equals a sub 1, cut. So we need to find the first term. Well, our rule, or our function, the general rule for geometric sequence, a sub n equals a sub 1 times r to the n minus 1 power. Now we're going to plug in one of our points. I'm going to plug in the smaller one. Those are just easier numbers to work with. So a sub 2, which is 10, is equal to a sub 1, times the rate, which is negative 2 from down here, raised to the n minus 1 power. Well, I'm plugging in a sub 2, so this is going to be raised to the 2 minus 1 power. Okay, so 10 equals a sub 1 times negative 2 raised to the 2 minus 1 power. Well, that's just 1. So it's going to be negative 2 to the first power. So 10 equals negative 2 times a sub 1. Divide both sides by negative 2, and we get negative 5 is equal to a sub 1. So now that we have our rate and we have our a sub 1, we can write the explicit formula. A sub n equals negative 5 times negative 2 to the n minus 1 power. And like we do with arithmetic sequences, you can plug in 7 plug in 7 for n to see if we get negative 320. So negative 5, and then parentheses, negative 2, raised to the 7 minus 1 power. Whoops. And we get negative 320. So that makes me confident that this is correct. You know, in case you need to look at the whole problem and all the work, there it is. Now this one, again, is going to be even more complicated because this one on the left had a sub 2, which is only the next value after a sub 1, and that's what we needed. This one doesn't have a sub 2 or a low one, but the process is going to be exactly the same. So the difference between 9 and 7 is 2, so r squared equals 1/8 over 1/2. And we can type that into the calculator. Alpha y equals 1 divided by 8, or 1 divided by 2. And that gets 0.25, which is 1/4. So 1/4. So r squared equals 1/4. And when we square root both sides, remember we square root the top and the bottom. The square root of 1 is 1, and the square root of 4 is 2. So the r value here is 1/2. All right, remember, a sub n equals a sub 1 times r to the n minus 1 power. So I'm going to use 7 and 1/2. So 1/2 equals a sub 1 times my rate, r is 1/2, raised to the n minus 1 power. Well, the n value for 1/2 is 7. So 7 minus 1 power. So 1/2 equals a sub n to the times 1/2 raised to the 6th power. Now I'm going to type that into my calculator. Alpha y equals, there's my fraction, 1 divided by 2 raised to the 6th power. And we get 1/64. So 1/2 equals a sub 1 times 1/64. Well, how do I get a sub 1 by itself? I multiply both sides by 64. These cancel. So then I'm left with 64/2, which is 32. So 32 equals a sub 1. My formula, a sub n equals a sub 1, which is 32, times 1/2 raised to the n minus 1 power. And you can go ahead and verify, plug in 9 for n, and you should get 1/8. Right, like I was saying, I want you to go ahead and try this one. Pause the video, and once you're done, unpause it and see if we got the same answer. All right, here is the final answer with all the supporting work. So go ahead and check your answer and then work to see where you made a mistake, if any. So thanks for watching the video. Make sure to like it and subscribe.